because otherwise it...
Okay, it's recording.
Alright, so, least common multiple. What is a least common multiple, for those of you who were just discussing it? Yes?
Okay, find the common factors in the one that is the least and the same.
You're on the right track, but not quite. Yes?
Find the numbers by time, that times the other number.
Not sure I understand what you just said. The lowest number of what? Okay, good. You said factors when you should have said numbers. That was the only thing that's wrong with the definition. Okay, so it's the lowest number that is a multiple of both of the numbers that you're trying to find the least common multiple of. So today I'm going to give you a situation here, and you're going to be able to work on the problem that has to do with this situation. And we're also going to come up with our own ideas of how finding least common multiples might be helpful. So, for instance, here, cicadas. Let's talk about cicadas for a minute. Cicadas spend most of their lives underground. Some populations of cicadas come above ground every 13 years, while others come up every 17 years. Although cicadas do not cause damage directly to fruits and vegetables, they can damage orchards because the female makes slits in the trees to lay her eggs. Cicadas are sometimes mistakenly called locusts. A locust is actually a type of grasshopper that looks nothing like a cicada. The error originated when early European settlers in North America encountered large outbreaks of cicadas. The swarms of insects reminded the settlers of stories they knew about swarms of locusts in Egypt. Folks at the back table, you're being a little too loud. I can't hear myself think. Thank you. Alright, so here are some cicadas and some locusts.
They look sort of the same.
They're similar, but they're different.
How are they similar?
Ladies and gentlemen at the back table, if you cannot whisper, I'm going to ask you to join this group instead. Yes?
I see a cicada.
Yeah, I saw a lot of cicadas this year. This year there was a big crop of them, if you will.
Well, actually, I saw one in Japan, and they live in the trees, and they wake up instead of the birds waking up.
Yeah, they're pretty much everywhere. Yes?
How big are they?
About yay big. I had one actually fly into my head this summer. I was excited.
Into your head?
Like,
Oh.
Grasshoppers like
grasshoppers, they would range in size from about that big to about that big.
Yeah, I would definitely know the difference though, because I have a leopard gecko.
I've like this before.
Yeah,
Alright, so it's a little bit more background information about the cicadas. Female cicadas lay their eggs in tree branches. When the young cicadas hatch, they drop to the ground and burrow into the soil. They remain underground for 13 to 17 years, feeding off juices from tree roots. Several months before they emerge, cicadas tunnel to the surface and wait to come out. The mass emergence of cicadas is the key to their survival. There may be up to 1.5 million cicadas per acre. There will be, many will be eaten by predators. However, enough will survive to lay eggs, so a new generation can emerge in 13 or 17 years. Yes, ma'am?
Some of our trees, since of all the cicadas, some of the trees start getting damaged from them.
Yeah, and that happens. They damage the trees mostly because the eggs are in the bark of the trees. Alright, so this is a situation in which we may need to find a least common multiple. Okay, and specifically in this next question. We've got a situation where Stephen's grandfather told him about a terrible year when the cicadas were so numerous that they wrecked the buds on all the young trees in his orchard. Stephen conjectured that both the 13 and 17-year cicadas came up that year. Assume that Stephen's conjecture is correct. So these are two cycles that are happening at the same time, but they come up at a different time. One of them takes 13 years, the other one takes 17 years. So in order to solve this problem, what do we need to find? Yes?
The least common multiple.
The least common multiple. Alright, so I want you to think for just a moment about another situation in which you might need to find a least common multiple. We've talked about this one. We might have hinted at some other ones. What are some situations where you may need to find a least common multiple in order to solve a problem? A real-life type problem. Okay, discuss with your. Ready to go.
Maybe that. to find the least common multiples here, maybe times those two times
Like
each
another
of
situation.
another situation where you would need the least common multiple.
Yeah.
Maybe where you can
Maybe one time
the least common multiple.
I will. What is the
So you can
situation
times it
where in real
times
life
that number by a lot
you
of
might
them,
need
and the
to
one
use
that's
a least
least,
common
the
multiple?
smallest one, that is missed.
Actually, it's not that. It's so there's like two different numbers, and you have to find what number both of them can go into, and the lowest number is the least common.
Really? Okay. So another situation for this one that would have to go into it would be like,
So we found two. What's the other number? Oh yeah, correct.
I don't know. Maybe every 12 years and every 17 years.
All right, class.
Yes.
What are some of the ideas you came up with? Go ahead.
There's two girls in their hair grows at the same speed, and they're trying to figure out when their hair is going to be the same.
And one girl cuts her hair every 13 years, and one girl cuts her hair every 17 years.
Wow, they have long hair, I'm sure. Okay, so you might be trying to figure out when are they going to cut their hair at the same time. Like when can they go into the beauty parlor together? Right? Okay, what have you got?
Cashier maybe, because
What?
maybe like they have a bunch of
Maybe.
school or something. I told you it's a deal for one of them.
Okay, so if we've got some sort of a deal and we have different quantities that we need to get, okay, kind of circling around a good idea. Yes?
One, if you're a scientist, and two,
Oh, if you're a scientist, what are you going to do as a scientist?
well, if this mad disease came out, and you had to find the least common multiple to get it rid of, but then you
I want a real situation. I want something that they actually would have to do. Okay, that's very creative, but I want something that it would require the use of a least common multiple in order to solve the actual problem. Go ahead.
Like if there were these two boys and they played football, one boy played in a major game like every 3 years, and the other one played in a game every 7 years.
Okay.
When would they play in the same game? Or a
Okay,
game
a
at the
probably
same
more
time?
realistic one would be to take that down to like you do every third game or every fifth game or whatever, rather than in years. But you know, like like let's say that your 7th grade brother has a football game every second Friday, and your 3rd grade brother has a football game every 3 days. When are they going to have a conflict? How often are they going to conflict with each other? Yes.
and they made two perfumes, and one would come out every 2 months, and then another one would come out every like 6 months. You could find a time when they would come out.
When they
together.
come out at the same time. Okay, good.
Maybe like two guys. Well, there's one guy that deposits his check at the bank every 3 days, and one guy deposits a check every 7 days.
Okay, when are they going to run into each other? Good. Yes.
If a girl went to school every other week and another girl went to school every like 3 weeks, usually
They
in, like
fail
college.
school.
No,
I mean-
they were, like an art class or something like that. And when would they both go to school at the same time?
Okay. Good. Go ahead, Tom. Last one.
There's 2 watermelons. One
Why
is
am I not
planted 3 months
surprised?
before the other one, but the one that is planted second grows twice as fast. When will they be the same size?
That would involve other things besides just least common multiple, but that would be involved in that, in figuring out when they would come out. All right. So, as you work on these problems, you're going to figure out when these cicadas are going to appear at the same time in these different situations. We've got 13 and 17-year cicadas, then we've got 12-year, 14, and 16-year cicadas. When are they all going to come out at the same time? And then you're going to explain whether this answer is greater than or equal to the product or multiplying these ones together. Yes, sir.
Do you have to do the problems?
For a point.
But taking notes on the lesson, isn't that a point?
That is a point. But, you know, you can always use more points, right? Yes.
So are we supposed to
Okay, yes.
What goal would this point
This
be
is
on?
for goal 4, I believe. Might be goal 3. Double check it. Yeah, this is goal 4. All right. So, we're going to go ahead and rotate. I'm going to end this lesson. And if you are working on the problem, go ahead and get started on that. If you are coming to my next lesson, it is going to be on how to make sure you've got all of the factors of a number. Okay, so go ahead and rotate. I'm going to give you about 18 seconds to get moved to where you need to be.
Is it still
Do
recording?
you want me to stop from recording?
Yes.
Well, do you want me to 1 second? Do you want me to stop it recording?
Hi, I'm Kyle.